Hey guys, during our remaining time together, we're going to do Chapter 9, Probability. It's the end of the unit on Sets, Logic, and Probability for IB Math Studies. Prior to spring break on Thursday, March 12th, I did hand you this packet, so presuming you still have it in your possession, you don't need to print it. If you don't have it and you are able to print it, there's a blank copy on my essay. So Chapter 9 is going to introduce you to probability, and through distance learning we're going to post some videos. You guys are going to work some practice problems, and perhaps there'll be problem sets plus other assessments on this chapter. So there are 11 sections running 9A through 9K, and since we have time together from now until May 8th, our last day, that's what we'll focus on, just getting this chapter done in a pretty relaxed time frame. Okay, so in Sets, Logic, and Probability, you'll see here that there are looks like 6 probability formulas that are on the IB formula sheet, and some little cliff notes, some shorthand notes on the material right here as well on the page 2. Move on to page 3. If you were in class on that Thursday before spring break, we got a little bit of section A and B done. So let's just do a little bit more of it right now. All right, so starting from scratch, section 9A is on experimental probability. And in this idea, basically, we're going to introduce you to the idea that probability is the mathematical part of statistics where we'd like to know the chance or likelihood of an event happening. So there are going to be many ways to establish probability, both through observation and through rules. So experimental probability means we're going to find probabilities just through observing some chance process over and over. Well, anyway, some introductory notes are that when we express probability, it's always going to be a number between 0 and 1. So if you look at this little chart right here, probabilities of 0 would be associated with an event that's impossible, and probabilities of 1 are associated with an event that's certain. If we're right here in the middle, we're at that 50-50 spot where we have an equal chance of something happening or not happening. If we're below 0.5, we're kind of in the more not likely to happen range, while above 0.5, we're in the likely to happen. And then as we close in on 1, we become more very likely to happen. And as we close in on 0, we could become very unlikely to happen. So when we assign probabilities, we're going to observe results or we're going to follow some rules. So we're either going to do experimental probability where we observe, or theoretical probability where we follow rules. This section is going to talk about experimental probability. So we're going to observe a chance process. We're going to have to know how many times that we've done something. We're going to have the outcomes would be simply the results possible for one trial. So we call those outcomes. The frequency of an outcome is the number of time that outcome is observed. And then here's where we get into experimental probability. This word relative frequency is simply a fraction representing the total number of times the outcome occurred out of the total number of trials. So if we had some small plastic cone and we kept on dropping it on the floor, tossing it in the air, letting it fall, it could either land on its side or base. If we do this thing 279 times and we watch it land on the side 183 times and on the base 96 times, then we have a relative frequency of each of the outcomes expressed as a fraction, or IB style, a 3 sig fig decimal. Okay, so basically, experimental probabilities are simply relative frequencies from watching the chance process over and over. So a couple of notation things become important as well. Notation-wise, we like to call probability with or notate with an uppercase P, and then in parentheses we simply describe the outcome of interest as either being probability of landing on a side or probability of landing on a base. Okay, some practice problems. Again, if you were in class on March 12th, you have these filled out, but let's go ahead and fill them out together here. So if we look at this exercise where sorry, distracted for a second. All right, so we have Jose surveying the length of TV commercials, and we want to 3 decimal places the experimental probability that a randomly chosen commercial lasts 20 to 39 seconds. All right, so a frequency table of something you would have seen in the stats chapter on descriptive stats in chapter 6. So if we look at Jose watching commercials, adding up the frequencies, you can see that he's watched 78 commercials. So now if we want to express in probability that he watched a commercial that was 20 to 39 seconds, we could see that he did that 38 out of 78 times, or as a 3 sig fig decimal 0.487. Part B, more than a minute, so that would be the 60 plus event or outcome. And for that outcome, that was only 4 out of 78, or as a 3 sig fig decimal 0.0513. And then 20 to 59 seconds, we'd have 38 plus 19 out of the 78, or 0.731 to 3 decimal places. Second exercise. Now we have a frequency histogram, or a column graph, I should say. So if we look at the number of phone calls that Betul receives over a period of days, for how many days did the survey last, you can figure out the sample size by just adding up the frequencies. So if we just by eye kind of catch the heights of each of the bars, we'd know the frequency for the total number of calls over the period of time. Okay, so apparently she took a survey across 43 days. Part B, each of these wants an experimental probability just from the information in the column graph. So the probability of no calls, well, that happened 2 out of 43 times. The probability of 5 or more, if I add up those frequencies, that happened 8 out of 43 times. Okay, and honestly, if they don't ask me for a decimal, I don't spend my time making decimals here. Answering probability questions with fractions, decimals, or percents are all fine unless the instructions want a specific format. All right, so less than 3. That looked like it happened 11 plus 7 plus 2 out of 43, or 21 out of 43. Okay, so we got a 2 out of 43, an 8 out of 43, and a 21 out of 43. All right, I don't see any point in doing this fourth exercise here, because that's just similar to the one at the top. I don't see any twists or turns there. Final part of section A, continuing experimental probability. All right, remember our goal is to interpret statistical information for many situations, and ultimately we're taking this given information and computing some relative frequencies for the event or outcome of interest. All right, so in section 9A, we have a table showing a survey conducted at schools on the rate of smoking amongst 15-year-old students. Notice we have to be a little bit careful that we've got columns of 15-year-olds, male versus female, and then over here we have number of smokers, male versus female. And we have that for 5 different schools. Okay. so we go to answer part A. Find the probability that a randomly chosen female 15-year-old student at school C is a smoker. We're focusing on school C, and we're looking for the chance that a randomly selected female at school C is a smoker. So at school C, I see 13 female smokers out of 49 females. Okay, so we were already told to look at a randomly chosen female, these, and of these, how many are smokers? Part B, find the probability that a randomly chosen 15-year-old at school E is not a smoker. So at school E, you can see school E, we would have a total of 79 students. Didn't mention gender, so we total up to 79 students. And then not a smoker, okay, so not a smoker. Apparently there's a total of 11 smokers, so that means we must have 68 out of 79 non-smokers. So you see this is nowhere near as simple as the frequency tables in the beginning of section 9A. These frequency tables are a little bit more just a little more complicated. Finally, in part C, if a 15-year-old is chosen at random from the 5 schools, what is the probability he or she is a smoker? Okay, so across all schools, we would have a total of 415 students, and the total number of smokers looks to be 92. Okay, next problem. This table describes complaints received by a telecom company concerning internet services. Okay, so in part A, we have to look at the year 2008-09, so that's this column. What's the chance that we got a complaint about customer service? Okay, so right here, 1181 out of 85. Part B, at any time during the 4-year period related to billing, so we need any time related to billing. So we're going to have to go, just do some addition here. That's the total complaints about billing. And then I need how many total complaints overall. So again, just addition to make the frequency in the numerators and the total in the denominators. Okay, I didn't finish working that through. Part C, if I'm in the year 2009-10, let me erase the marks I have so far. So 2009-10, not relating to billing or faults. Not billing, so not this, not this. Okay, so that means 9,109 total complaints, and then the numerator would be not, so I'll just find that by subtracting from the total. Okay, so whatever that works out to, I don't have the final answer on that one either. Okay, 9A is done.